All right. Hello, guys. Welcome. So, today we want to take a look at finishing the issue about adding new info to the RB2 elements or RB3 elements. And I think the obvious way forward would be to add the moment information, but for that I don't have actually a model right now, so we would have to design something for that. And I think the best way forward here would be to take the flange model, because I think that's a good model to do that. I mean, yeah, it's pretty reasonable to have something like a torque. We defeatured it out, but there was some features here that would allow for torque transmission. So I think it was intended to be used like that. So it's not a, yeah, flange, it's a flange connection. So it should transfer torque. So that's not being modeled right now. But we can model that. Yeah, so let's start with that. So instead of having this force here, let me hide this component real quick. Instead of having this load here, let's delete this one and let's create a torque. Therefore, I would need all the components again. Now, let's add a torque, and let's also make sure that we have the correct load collector selected. So that would be the force load collector, the loads load collector, not the SPC load collector. Now, I would apply 50 Newton meters in direction 1, 0, 0, 50 Newton meters, and we have Newton millimeters, so there's additional 3 zeros. Create, I don't really care much about the direction, if it's this way or the other way. Should be the same thing. Let's just run that. Let me quickly check in the sound thing. Yeah, so analyze this. Now let's do that as flange moment. All right, I'm running that one. And then let's see. I think this is the model without any of the context, right? So the context definition is not here. So give me a second, I have to just make sure that I don't over brew my tea, that it's too bitter. Would be a shame. Oh, wow. That's too bitter. Yeah, drinking jasmine tea today. Pretty cool tea. I like it very much, but for jasmine tea you have to be super careful. Because if you have that too long in the water, then it will be very bitter. And that's not what you would like on this day. Alright, so okay, it ran through. I want to just quickly copy the model into our input folders, that we have that at the correct place. So that would be, you cannot see that, but I'm doing that on a second screen here. So that would be flange moment. We need MPCForces and we need the .fem file. And we put that into the input folder. Alright, having that, we can now go into the MPCForces file. Basically, to be honest, we could also start the implementation right away. Why there's a to-do? I think we can leave that away. So we are here. And here we have to change the model name. So that would be flange moment. So this should work. If I run that now, that should work. But we can implement the things right here. So basically just occurring to me that forces.py maybe not so good at naming. Let's rename that. Let's rename that to loads. Extension Python wants to make refactoring. Yeah, show preview. Yeah, I would say apply that. That makes sense. So now because we can now also give a class moment. And yeah. Maybe it's exactly the same thing as the force. But I will check that first. So basically we could just now go into the FEM file, because the FEM file for the new model should have this moment in it. So input and then flange moment, right? So and here to the bottom there should be the moment, right? And you can see that it's almost identical, I think. It's pretty much identical to the load. Okay. So let's say that this is identical. Then I think this implementation the Copilot just gave us would make perfect sense. All right. Okay. So let's just assume this works. Then let's go to the model reader and see where the forces are being created. So we have a get forces. Maybe we make that also a little bit different. Let's say that's loads, get loads. Okay, it's being not executed from here, but I'm already sure where this is. Should be here. Yeah, so let's make get loads. And this gets loads method that extracts loads from the FEM file, currently forces and moments. Okay. All right. So if it starts with moments, that should be basically the same implementation. But here I would say that would be a moment ID to a moment. Because we have to distinguish between the loads. So we should distinguish between forces and moments. Basically, we could do that also with the class, because we can say it's instance of, right? So we could maybe also make that something like a load ID to load, because that would be then more or less both. Let's try that, if that works. Not 100% sure that this will work. But let's say we have this collector load ID to load, right? Compared to the initial one, force ID to force. Oh. Okay, it's just this one. Oh. Alright, so this would be that. Now, in the MPCForces, in the MPC tools, when we write something out, there is something. We have to be a little bit careful here. Yeah. Okay, we make that like this, because then we can really, we don't have to change much here. Careful, be careful, be careful. Yeah, here it is. So let's say this is load, and this is for sure not forces, but load ID to load. And yeah, so then we have load X, Y, Z. That makes sense because it's the same thing for both. Then we have here load. If no. Well, if load instance. Oh, I think I think I mix Python and Java again, but I would just wanted to write instance of. No, that's not making sense. That doesn't make sense. Let's use GitHub Copilot. Check if load is a force or a moment. That doesn't make sense. Chef. Check if load is instance of force or moment. Load type. Yeah, maybe that works. So, load type is none. If it's force, then it's force, and then if it's moment, then it's moment. So this makes more sense. And then we can have something like this. Load type. So basically that makes a lot of sense to do it that way, because then we don't have to have duplicate code. Alright, so here we all have to do something like this. And I think I can just copy and paste that in here. Okay, so we still have problems here. Why? Because there's load ID still. Yeah, basically it's a lot of replacement options here. Yeah. So why is this not being used? Oh, I think there is no XYZ there. I have to do it like this. Alright, that makes more sense. Now let's get another bitter taste of this brewed jasmine tea. Next time I have to do it better. Alright. Okay, so this works now. Then I think there's another place where I have something like this. Let's see if there's another force ID. No, there isn't. Well, alright, then let's just run that. Let's see where it fails. Or if it fails. Basically, what I would expect in the output now would be a moment at the master node of the last RBE3 element. That should be the expected output. Okay. Alright, so this doesn't make sense. I think I just have to import them, right? So that should work now. Alright, let's test that. And also let's test the T. Now I brewed it a little bit. Okay. That's better. Okay, from MPCForces cannot import moment from loads. What? Why? So we have in the data structure there should be loads. And that's it, right? And then we have the class moment. Why can't it import that? Huh? Cannot import name moment from SPC. Huh? So this is being saved, right? So there should be a moment here. What? So maybe something with a package. So in data structure, there's an init file. Yeah, I think there was just a save issue. Okay, so it wrote some output. Let's check that output. There will be flange moment here. So there should be something here. Force. Well, that's not good. Why is it a force? That can only be in the case that I created it wrongly. So the model reader. So there should be something. If that's a moment, then yeah, that's for sure not right. So they are pretty similar because all the arguments are the same. Okay, but I think it should pretty much work because it's the same thing. And I was wrong. Okay, moment, and then force ID. Okay, that's not expected. That should be moment ID. Node ID is expected. System scale factor component from file. That should all be okay. Yeah. Never trust Copilot too much. Bitter lesson. Alright, flange moment summary. Let's check that. See, there should be no moment. At master node ID 2, and we have the 50 newton meters. Alrighty. So we have the moment implementation already, so that was quite fast. Let's check the linting. Okay, that seems to be good, so I think we can commit that already. And then I would say that would be the moment loads implementation. That was fast. Alright, then what's the next step? Let's check. I think the next thing would be the connected 1D elements. But I think I will make a separate branch for this. Should not be rushed in this branch of adding output info. Because I'm sure that having 1D elements will require some models for that, and not just one. I think that will be multiple models. And yeah. So I think there should be a separate branch. And by the way, I think we already have the issue, right? So we could just create a branch and start working on this one. Yeah, and I think that's exactly what we were gonna be doing. And the other thing, which also is a little bit neglected now, is the testing. I think test coverage is pretty awful. Let's say that's here. I have to check that in the Explorer and just go into the index.html. So if I just look at the coverage, well, it's pretty awful. So yeah, but well, it's a prototype still. I think it's okay because it's changing a little bit. But to be honest, so in my stomach feeling, it's converging to be. There's not too many more things I would think of this program or this tool has to have right now. So if we just look again at the issues, which I could think of. So we have this add more info to rigid elements. I think we can say this is now complete. So we will merge this, and this is off the chart. Now add more tests, that will be done at the end. Then we have this 1D element implementation. Think about the RBE master node. And that's duplicate, right? So this bolted connection is the same thing as the CBAR beam thing, I think. So let's just flag that for being a duplicate. Yeah. And this here, what's with the master node? Well, at least we have the forces and stuff like that to be something which is now also outputted in case if it's on the master node. Now I'm not sure what the forces of the master node should really do, because it depends on what the master node is. Yeah, we have to check that. That I think with the 1D bar element model we will check that. Because here we can then see if the connection from bar to the master node has all the force which is transferred in it already. If that's the case, it would be pretty simple in such a case, and maybe we would not even need the tool in this occasion. But let's see about that. So I don't know. I don't know about this, to be honest. Okay, so let's check the pull requests. That should be changed from draft to something which can be now merged. Let's check if the commit was... No, the commit is not being implemented here. So did I push? I did push. But why? Why is the comment... why is the comment not here? Let's see. So this pull request has just 3 commits in it. So the newest one is not there. If I check the branch, if I go to the branch 19, I think the commit will be there. No. No. Wait a second. If that's not there, this has not been pushed. Moment loads implementation is on 19. Let's just make sure that it's being pushed to the server. That would be odd if it's not there. Here it is. So here it is. Oh, am I stupid? Is it just upside down? Self-assigned add moment. Yeah, it's there. I'm stupid. So basically, here's September 25 and not up. Yeah, alright. Alrighty. So let's check it quickly what we have here. So we have the linting thing. I can think we can get that. Then we have the loads.py. That's clear. Then we have the data structure widget. We have changed something here. We have the MPC config here as the enum. Then we change that to having positional arguments because we added, I think, a new argument to MPC config, right? Yeah. So we have that here. Wait, then we can have that as viewed. Then we have the test methods, which is more or less just, yeah, it's not that sophisticated. Then the MPC tools, that's the main method. This has now force loads. Reader get loads is the main method of getting the loads from the FEM file. It's being implemented rather stupidly because we have this line content, which is just the complete FEM file, and I'm looping through the FEM file multiple times, and I'm not even caring about the position of where the loads start. So yeah, maybe that's a thing we should do. Not in this branch, but later on, performance-wise. Just think of it if you have a file which has millions of lines, and at the bottom 50 lines, at the bottom 50 lines, there is the force and loads definition. And what I'm doing right now is I'm going from 1 to 50 million or whatever lines we have and extract the loads separately. So at least what I could do is doing something like a sweep through and identify where the sections are starting, saving this as variables. And then when I later execute this method get loads, I could just look up what's the line number where the load section is starting, and let's just jump there. And yeah. Hey Alex! Good to see you. Good evening. Yeah, so performance-wise, there's still a lot of things to do. But other than that, I would say we are converging slowly but surely. So the model reader has also some things to it. Yeah, we have the load ID to load, so all the loads thing. Yeah, but this is what I was just talking about, right? It was this thing that you have this FEM file reader. Then I think you have something like read lines, right? Don't know if you see that here, but I don't think you see it. But what I added here is get loads, and you see for I in enumerate self file content. So it starts with I equals 0, so first line, and then sweeps all through and just ask whether the line starts with force or a moment. And you basically there is one easy fix of having that performance boost. You could just do it the other way around. You could just do it like start from the last line and move your way upward. But on the other hand, this doesn't really improve the performance too much because you're looping the file completely, as you don't know whether in the first line or the last line, respectively, there would be a force hidden. So performance-wise, I think we have to do some homework here, but otherwise, I think it's pretty good. All right, Alex. Since you've been here, I don't think you have been here yesterday, right? And I think we made some good progress on yesterday. Should I update you on the progress? I think that it's just fitting right now because we have now completed something like a pull request, and I will merge that one, and then I can just give you a little glimpse on the whole program, what it does right now, and what's the current status. So let's merge that thing. Merge pull request. Delete the branch. And then let's switch to the development. The development, and then let's do a fetch and pull. All right, and I will brew myself another round of the jasmine tea. I have to be careful not to forget about it. Yeah, recap for sure. Yeah, good thing. I think that recap is pretty, yeah, it's a good thing to do that from time to time because when I'm talking about what the current state of the program is, it's also something which makes me realize what's still missing. It's the same thing as if you're trying to explain a problem to your colleague, and the colleague just have to be there and listens. And while you're explaining, you're realizing where the problem is. It's a little bit awkward that it is like that, but yeah, it's very very good to know that sometimes you just need someone to listen, and it will magically solve the problem for you. You still have to do the work, right? So, but yeah, so um, basically, let's just cover what's the current status. So right now we have this model as a test case, and this model has the 3 RBEs or RBE, yeah, the 3 rigids, RBE2s outside, and it has this RBE inside here, or yeah, on the end of the part, which is being used for moment transfer. And this is the RB2s here. This is modeling rigid bolt connections, right? So nothing with a stiffness, just rigid bolt connections. And the tool is being used to just identify which force or how much force is being transferred for which of the connections. Now, we started with the neighbor detection thing. That did not work as good as we hoped because of performance issues. Then we said, all right, let's do the graph thing. Then this worked, but it did not work for the broken.fem. And the broken.fem, just let me quickly walk back. There would be data input broken FEM. Bam, 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 bam. Rigid 3D mid broken. Yeah, let's just quickly drag that in here to just see what I was talking about. So the broken FEM model has a refinement here. And the problem was we were dealing with subgraphs. Subgraphs meaning we had built a graph for a complete model. And then we did something like a subgraph, which only the nodes of the slave nodes of the RBE was being taken into account. And then we looked for connected subgroups. And that resulted here in 180 different subgroups, which is not the expected behavior. Then I think the breakthrough idea was to just make the connected groups in the whole graph. So you're just doing this dissection into different parts from the whole graph. So you have a yellow part and then you have a blue part, right? With all the nodes. And then you have to change the way you are getting the groups here. So by each RBE you're just taking the connected groups from the whole graph and make this intersection of the slave nodes and each group from the whole model. And then you have maybe some parts which have 0 elements. So that would be maybe a third part, right? Which is connected with a different RBE. For this RBE, the intersection with the complete graphs, complete groups. So complete connected groups is completely the same thing as parts or connected or nodes of the parts. So you have yellow, blue, and green. Green is not there, but just imagine it would be there. So you have yellow, blue, and green. And if you do for each yellow, blue, green, you do intersection of the slave nodes of this RBE with the part. So intersection slave nodes with yellow give you exactly those nodes here, right? Intersection with blue, exactly those nodes, and intersection with green, none, 0. And this is how we find out the grouping. And this is more or less the current implementation, how it's done there. And this makes this model work too. That's pretty nice, I think. Because now we can safely assume that, at least to my knowledge, I cannot think of a configuration of the RBE for which this would break. The only thing which would break that is if you have a connection which is the same node of two nodes here, because then yellow and blue would be seen as one part. This will break it. All other things will not break it. Yeah. That's it. And now we have been working a little bit on the output. So just see what the output looks like. So for now, if we have the flange moment, that's the latest model we've been working on. We have the summary, right? So this is still the same up here. But then you see the MPC config has been written out too. So I know exactly if that's an RB2 or RB3 element, which makes a lot of sense. Just how to interpret the data lines here. If that's RB2, it's a little bit different than an RB3. And then you also have something like the first 5 slave nodes for this part ID, because part ID doesn't mean anything to the user. Hey, good evening. Yeah, welcome to the stream. Yeah, so yeah, you have this first 5 nodes, which you just can copy and then mark them in your hypermesh model to just know which part is it talking about, because part ID, that's nonsense. It's just an ID counter. Yeah, so this is being added, and lastly, there is something added which is just being shown on the RBE with ID 4, which is an RBE3. You see that there's a moment at master node ID 2, and then you have some values for X, Y, Z. So this is detecting if there's a force or a moment applied to either a master or any of the slave nodes. And if there would be multiple moments also, it would be done there too. So now we could also do stuff like that, which load case ID is it, and load steps and something like that, but that's on another page. Right now it's just simple single load step files. For RB3 you have a different method. No. Basically there's not really a different method for that. If you just look in the how's it called, entities? Wait a second. So if I look here in the data structures entities, we have this element and we have this element 1D, and yeah, it's not entities, it's rigids. Well, this is also not really good, but rigids. Yeah, you have this class MPC and that's all there is. You have class MPC and there's MPC config. And the MPC config can be RBE2 or RBE3. And basically, with initialization, you have to specify, is it either a RB2 or RBE3. For right now, just those two are supported. Yeah, but it's important to know what the configurations is, because they're pretty. The implementation is different, right? So, for example, dependent and independent nodes, they switch from RB2 to RB3. So that's a little bit, yeah, you have to be sure that you know what you have. All right, so this is it. Now, I think we can now go to the next issue. Yeah, not quite. Switch case is yeah, basically it's a switch case, but it's implemented differently. It's implemented like with if statements. And you can see that in the reader. So the model reader, where the RBEs or rigids or MPCs, however you would want to call them, are being generated. That's with the method getRigidElements. And then you have this, if the line starts with RBE3 in the .fem file, then it has this lines of setting it up, and then if it's instead RBE2, then it has this lines of setting it up. And you see here the MPC config is either RBE3 or RBE2, and is being used then here when this MPC is created. So basically, you could interpret this as a switch case, this statement, for the line starting argument, for the keyword, you could say. But it's modeled different. It's modeled with if statements. Yeah. And by the way, did I already boast about the running times? So if you can imagine, if you can remember what the running times were with the 156K model, I think that was quite slow at the beginning, right? And I'll just open again the flange model, because I think the flange model is the model with the most number of elements for right now. I'm not sure. It's definitely not 156K, but 50K. Yeah. And 50K elements. But I think it's rather important to guess to get the node size. Yes, around the same. So 56K nodes. So that's a factor 10 off to 500,000, right? So that's not bad. It's quite some nodes. And if you just think of the running times, I think it has been run here, but let's just make it sure that we have the correct version. So the correct numbers. And we quickly go to the MPC tools and close others. Now let's check the model name, flange moment. Yeah, so this is exactly what we've been talking about. Now if I do a task run, I'm pretty amazed at how fast it is. So I was fearing that that doing the complete graph would take a lot of time, but just look at those numbers. So 3 seconds to load in the FEM file. Not really optimized. And then building the MPC 0.07 seconds, and then calculating connected components takes 0.09 seconds or so. Yeah. I mean, that's nothing. That's nothing. I'm not sure about how it scales. If we maybe have something like wait a minute. Let's maybe do that. Let's do that just for fun. Let's do that just for fun. Let's make something here, and let's just make this is the flange model, right? With the force, not the moment. Let's just split the elements here. Split solid all elements one time. Now let's see how many elements do we have now. 380K. So let's analyze this. And we will call that flange fine. And then let's see. But my assumption would be that this having 6 times the nodes will take maybe around 6 to maybe even less. 6 to if it's linearly scaling, I'm really happy about that. So that would be 6 times 6 times the time. That would be 5 seconds times 6, so 30 seconds. This is what we would have been assuming. But if it's not scaling linearly, because I cannot really make the case for the graph, not sure on the graph. So it could take also maybe a minute, but even if it's a minute, I mean, we're talking now about almost 500,000 nodes, 500,000 elements. What's the node number? What's the node number? Yeah, around the same. So 420K nodes. Now, just for information, this is now having 1.6 gigs of RAM for the in-core solution, and will take maybe a couple of seconds to do it. Well, subgraph, we're not using the subgraph anymore. We are using just one time the graph of the full model, and we're using then the connected elements or the connected groups we get from the complete graph. We're using that for each and every RBE element. But the intersection calculation should be pretty easy. If that's not optimized, there's certain tricks of how to optimize it. For example, you could sort the node IDs in the connected groups. And if you have that sorted, and if you have your slaves sorted, then the intersection would be pretty trivial. So this will not take too much time. But yeah, then you have to sort it. Sorting is something where you have to be careful, because sorting takes a lot of time. Especially if you do it stupidly. If you just do like a non-optimized way of sorting, then it may take, I'm not sure about running times, but I think a typical running complexity for sorting is, I think, n times log n, or n times n minus 1, or something like that. I think n times log n. So it's not good. I think what's some typical sorting algorithms? Quicksort, for example, that would be one of my choices to implement. And then, yeah. But to be honest, there may be also even better opportunities. Yeah, IDs. Because you think that the task you have is, I want to have the intersection. So what is common between two arrays? Let me quickly draw that for you. Okay, let's just say we have the full model, right? And the full model, oh, sorry. Okay. So, oh, sorry, somehow my Wacom tablet is not working. It's just taking the... Wait a second, I'm restarting the tablet. Hopefully this fixes it. Because, you know, it's now controlling the wrong monitor. And you cannot see it what's in there. Oh, that's a shame. All right, so I have to do that with my mouse, which will not be precise. Okay. Excuse me. So let's just say you have one array and then another array, and this is your connected groups. Yeah, you have your nodes here for one part, and here's a node set of another part. This comes from the complete model, so there's no subgraph, nothing. And then you have your MPC. This MPC now has also some slave nodes. And it has slave nodes from here and from here. And you now have to do the mapping. What is common here and here, right? For example, like this. You don't know where the position is, right? So I'm not sure how the intersection method is being implemented, if that's scaling good or not. But if you would do the stupid approach, you would do maybe something like this. You would go here and say, for every node I have in my MPC, let's start with this one, I'm looking through all these nodes if I found it. Okay, I found it. All right, I'm returning that, and that's it. Yeah, I'm drinking tea. Yeah, but maybe I have to also drink some water. Yeah, so this is the stupid approach. But if that's not sorted, the worst thing could happen is that the first element you search for, where's my mouse? Here. The first element you search for is the last element here. The second element you search for is the last element here. And then you're doing a n by n minus 1 by n minus 1, 1. Yeah, you get the idea. You will have a large running time. But if it's sorted, you can assume that you have, yeah, that the intersection will be a lot faster. But even that is not optimal. I would say the optimal solution is something like a map of having this at the exact same points, and then just do something like a bitwise addition or something like that. I'm not 100% sure, but there's 100% a bitwise method here available, which does the intersection in constant scale. So it doesn't matter how large the array is. But there has to be some preconditions. It could be that you have a lot of memory requirement for that one. All right, so now while we have been chatting about sorting algorithms, the model has been run successfully. So I can now copy that into the input folder, and then let's just see how we are. So I will copy the FEM file, which is, by the way, 58 megabytes. So has a bit of size. It's not a lightweight anymore. And let's run that. So that would be flange fine, right? Flange fine. Let's run it. Let's see. And for me, it's time to drink some tea. So half a minute would be phenomenal. If it's below 1 minute, it's still pretty good. I think if it's below 5 minutes, I would be okay with it. But maybe we would have to look at something of yeah, some potential to make it a little bit faster. But to be honest, my estimation is that reading in the FEM file will still be the largest portion. And yeah. So 58 max. Just to compare, the flange FEM file has 7 megabytes. So it's roughly 8 times the size. And 8 times 4 would be 32 seconds. But I think it's taking longer than that. Yeah. I mean, reading the FEM file, that's also something which I think can be split into multiple things. All right, so let's see. 76 seconds for reading the FEM file. Now the building of the MTCs is also, I think, looping through the file again, but this only takes 0.8 seconds. So I think this building the file content array is what's taking so long. Also that, yeah, it's maybe a big memory requirement. Well, big, not really, but a bigger. Yeah, but I think that the timing is okay. I mean, yeah, I cannot see the... Wait a second, can I? Yeah, so here, 0.07. And then I think we went from 30k to 400k, so 10 times. And here we have a lot more. Yeah, it's more like 100 times. But still, I would say that the time it takes for calculating the connected components is not really that much. 1.79 seconds for 500,000 elements or nodes. I would say that's perfectly fine. So the biggest chunk we have is the reading FEM file. And yeah, basically, well, let's maybe see what this is. Reading the FEM file. Ah, I think we have to rename that. That makes no sense. Build node to property. Is that really a thing? But yeah, that's creating the elements, more or less, the 3D elements. But basically, you can see what is being done here is just one loop through the file content. That cannot take that long, to be honest. But that's all what there's doing, right? So reading FEM file, then build node to property. Maybe there's something hidden here. Yeah, FEM file, that's a finite element analysis file, yeah. Yeah, so It just creates the elements. Well, to be honest, the thing is, it creates a lot of elements, right? So 500k of instances being created, yeah. And then maybe there's something here. No, there's not. Oh, by the way, we have C-beams and C-bars and C-tubes and C-rods already. Haha. Because that's the next issue we are talking about. Ba-ba-bum. But this element, yeah. It's building the graph. Yeah, this I don't like really, yeah, but still that should not be a problem because it's just 4 no so 8 by 8 nodes or something like that for an hex element. Yeah, but if you're doing that 500k times, yeah. Yeah. That could be maybe a performance boost if we do that with the keyword implementation. But for right now, I will not care. For right now, it's perfectly fine. Having the user wait a minute or 2 minutes for 500k elements, I think that's pretty reasonable. So nothing too, too slow. But there's some speed up potential here. Definitely, yeah. All right. So, next thing. Next thing I want to take on is the 1D elements. And there's already I think there's already a model for that. But I'm not sure how it's being interpreted right now, because that model I think I've never run. Let's see. So there is this 3D bolt model, which has just a C-beam element between two master nodes of two rigids, right? And yeah, so this 1D element is also having a cross section for sure. You can see that here. So this is the cross section of it. So it has a defined stiffness for it. And let's just linger a little bit around why I think it makes sense to spend a little bit time thinking about something like this. So if you have something modeled here between those RBE connections, right? So this would be from the detail stage of modeling. This would be one stage above the initial one where we just have an RBE element connecting the two parts, right? So connecting the two parts with an RBE2 is just infinite stiffness between those two parts. So it's not really realistic, right? It's just a quick way to get a connection there. And having something like this is maybe even 2 steps ahead of from a detailed perspective, because I can think of something like a C-bush element, which is connecting the master nodes of two RBEs. C-bush elements have spring properties, so you can have something like a stiffness, but stiffness not just as a one-dimensional scalar value, but you can have stiffness components in different directions with a C-bush. And a colleague of mine told me that, because I wasn't aware of that this is being used heavily in the industry, but you have something like a RBE2 here and a RBE2 here, and then you're moving the master nodes close together, that they are just coinciding, is that even a word? That they just on the same location, so you're moving the master node from here down and from down up, then you have that both master nodes are there, one over the other, and then you connect those two with a C-bush element. And the C-bush element has then to be assigned a local coordinate system, and then can have, I think, 6 stiffness parameters. So for each degree of freedom, you have then a stiffness parameter. And basically, you can then also make a 1D bolt connection with perfect stiffness coordinates or stiffness properties. Yeah. Right, Alex. You're the man. Yeah, this is exactly what my colleague has been talking to me too. But to be honest, if I could ask you, isn't that a real heckle to just use this? I mean, you have to design a coordinate system for each bolt connection. I mean, for sure you can do that with macros, but it's rather tedious, right? And then you have to move the nodes on top of each other, and if you want to see if the C bush is there or not, you have to maybe move them away from each other and stuff like that. Is that really... I don't know about it. It sounds super... Yeah, it sounds like much work to me. And what would be the benefit of having that over a 1D bar connection? So where you just model that with a 1D cross section? Because that has also stiffness properties, right? So I'm not sure what would be the better one of doing it. Really, I have no idea. But I would like to take a look into the C bush formulation too. Yeah, just out of curiosity. Yeah, what we could do with that. But coming back to the point, why I think this is important. I mean, what for do we do this with the MPC tools, right? So we get the forces, right? But what for? Well, one of the main things is to just calculate something like if a bolt will fail or not. So just imagine you would have something like this. You have a C-bar element. That C-bar element has a start and an end node. So you can also get a direction. From the property values, you have the radius. Now, if you know the force being transferred at this location and that location, wouldn't it be possible to just have something like a F divided by A for stress formulation and just have some rough guidance or rough estimate if the bolt will hold or if it would break? I'm not sure about this 100% because bending for sure would not be taken into account, and yeah, for sure it would be better to just get the stress values from the 1D bar element. But just to having a rough estimate for a hand calculation, I think it would not make... I think it would make sense to have something in the MPC tools toolbox. Not sure what you think about it, but I think there could be a benefit of it. So yeah, it's a shame that I cannot... Wait a second. I will just try to get my Wacom whatever board to have... The tablet drive is not responding. Click OK to restart the driver. Alright, let's do that. But the thing is that if I just do my pen onto the tablet, I'm moving the mouse on my main window. And that's not good if I want to draw something, right? But I think I would have to restart the whole PC. Yeah. Sorry about that. So I cannot draw really, or not beautiful. So basically what I thought would be possible, if you have this MPC here, right, at the top, and then you have some MPC at the bottom, and between those two you have this 1D bar element. You know the direction. You can also get the perpendicular direction. You get the forces which you sum up from the MPCForces tools here and also here from the RVE. And then you can maybe do something with that. Make something like an estimate for if the shear stress would be too high. Something like that. For sure, there's nothing with bending and contact and stuff like that. That's all not being accounted for. And then, yeah, going further, you could also do, if you have the force here, could also do F divided by A for something like a pressure on the surface here. Yeah, so lots of things which you could do, but the problem is I don't want to blow this tool up to being a replacement for the Hypermesh and Hyperview tool chain, right? So this is not what the tool should be at the end. So I'm not trying to make a new Hyperworks out of it, right? That makes no sense to do that. But just think about what's reasonable and what's maybe interesting, and just having the 1D bar and 1D C beam or whatnot. So the 1D elements could be a thing to just couple two RBEs together, or at least, so the least what I could do is make something like, if a rigid is connected to a bar or beam element, I could just highlight that into the output and maybe sort the output by connected elements, so that I would have the same elements, the RBE elements which are connected to the same bar element, that they are in the same place at the output file, and not just one at the top and one at the bottom. Yeah. So this is me thinking about what was maybe interesting to implement, and yeah, so I think I will just start a little bit about yeah, with that. And starting with that means I would just throw in this model. So that would be rigid 3D bolt. And before I do that, let's first also do the branch for it, so that we have that. So this would be that one. Add C bar C beam elements for rigid element detection and model reader. Well, basically that's solved already. Yeah, but this is it, right? So it's in the model reader, and I think it would be detected, but it's not being, there's nothing being done with it. All right, so let's just do that. So let's create a branch for it. Then we have that. Next thing is to fetch it here. By the way, we have to get rid of all those local branches at some point. So add C bar C beam. All right, we have that. And now we can turn into the model here and check out what it should, what the name should be. So that should be this one. And then let's just see what the output will give us. Or if it fails. Could also be that it fails. I'm not sure what the 1D elements is really doing. It should not compromise our graph, I think. But there could be a compromising thing. Just imagine just imagine you would have a bar from here to here. I'm not 100% sure what the graph would do, if this is then a connected part or not. The reason why I don't have a problem with it is because the MPC's master nodes and all those nodes are not playing a role for the graph. And this is why I'm getting away with that. But there could be something. Not 100% saying that this will always work. But now let's check out the output data and see. So basically there should be now two rigid elements, so that's correct. And we have that, and we have just one part, and there's 500 newtons being transferred, and minus 500. So basically it works correct. That's a good thing. Now, we don't have any idea of the RBE2 element being connected to 1D bars or beams. But I think it should be rather easy to implement something like this. It should be rather easy to implement something like this. Because if I think about it, the model reader already has it. There is this thing called... There isn't? There is. There's this thing called elements 1D, and that's just an array. And I think it's not the rigid elements, but the build node to property, which is the worst name possible. That was initially the case. Let's just rename that. That is create elements or entities. What's in entities? Let's see. Does that make sense? So we have element 1D, element, nothing more, right? And node. Yeah, I think create entities makes sense. But there's no create nodes, right? Why not? Yeah, because yeah, okay, I see why not. Because the thing is, this create entities has to happen after the nodes are being fully created. That's also a pitfall I fell for multiple times during my PhD thesis. In order to being able to create elements, you have to have the nodes. That's also, by the way, that's also the reason why in the input file, the first thing you have is the nodes, right? You have a little bit of, yeah, stupid things here, but not really much of importance. But here, the first thing it starts with is the nodes. Why? Because those node IDs are referenced later on with the hex. So here it's referencing node IDs. If the nodes are not known, then what should that be, right? So that's not possible. That's why we have to do that separately. Because otherwise it would be not a bad idea to just have create all the nodes and then create the elements. One could argue though that the nodes always come at a line number which is lower than the elements. So you see that we have this. Do we even have that? I think we have that create nodes or something like that. But if I look again, where's the nodes being created? Read nodes, yeah. I see that we have a Yeah, I'm just thinking about how to maybe do a little bit of an optimization here too. See, when you're doing grids, yeah, as soon as as soon as you enter the grid block, as soon as that block is finished, there's no more grids to appear. Right? So those are the RB elements. Then you're done. So you could do something like this, right? You could do something like this. So line starts with grid. You say there's a Boolean variable, grid found, grids found, false. Then as soon as you are here, grid found's true. Now you do that all, and now you say if grid founds and not line start with grid, break. Birds. Because that would really do you a service. That would really do you a service, because just think about the FEM file. If you see my slider here on the right, yeah? So basically up to here is grids. So it's maybe a third of the file. And then all this looping here would be for nothing, right? You could even go further and you could say, I want to have the line number 2. So for I line in enumerate. So if I have that thing here, I can say self end grid line. equals I. I always can smell, I almost can smell the linter complaining about too many variables in one class. But it's pretty, it would be pretty convenient to have something like this. Let's maybe make a, no, a static variable would be false. I will just try that. Grid end grid line is none. Now you could have that read nodes being executed, and if you then have to create entities, right? Then you can do for I how we should do that. Can I do something like self grid line and then a colon? I think I can. So you're starting with the end of the grid line. So that makes also sense because then you're also saving 1/3 of the looping. Right? And then you're doing your elements. By the way, that's also completely valid for the RBEs. Right? So you can do something like that. So let's try if that even works. Yeah, I mean, I know I'm pretty, I'm not really working on performance right now. That's for sure. So we have a error here, and that's because we renamed the method. Build node. Is it not here? Should be here. MPC tools, yeah. Is it bullet? Okay, I even did the wrong node. All right, even better to get rid of that. So it's create entities. Let's see if it still runs. And I would suspect that now this time should be considerably lower than the one before. Yeah, you see? 4 and now 1 second. And to be honest, we just started. So with the other things, I would say it's a little bit more difficult because you cannot guess which is the hex or pent or whatever. But for sure, you could say if we have SPC, then it would drop. But to be honest, there's not much gained. The only thing which would be gained is, I think, if you just... What is this? I don't want to ask something. Okay, I think the only thing which you could do is having this being read in as a starting point for SPC data for the get forces, you know. That could be a thing because let's just search for up. Ah, no. Haha, I have to be careful. Have to be careful about this. Let's also check that if that's for nodes or true as well. So here's the RB elements. Because if the components is there, no. For grids, that's valid. But for the other thing, it's not valid. So I cannot really do that. Maybe we can do the double slash, the double comment sign. Yeah, I think that would work. Yeah, let's do that. Let's try that. So we're creating the entities, right? So we're looping through there and we're not caring too much about it. We're doing something like elements found. equals false. And then we say if element keyword in there, yeah, then we would say elements found is true. Because then we can do the following. So let me check where we are. I think, yeah, this should be it. So if elements found and no, and line starts with we can do a break, yeah, but this will not really matter too much. But we can say self and element line or entities, let's say element line is I. So self.end element line is none initially, and then we have that, and then somehow there's the read forces or get loads. Here we can do self.end element line. So we just have the bottom part. You are storing the line number after reading nodes for referencing for elements and directly go to that specific line and skip all the nodes. Exactly. That's exactly it. You can see that I'm doing that right now again here. So I say for I in enumerate self file content and then self end element line colon. That means I have just a subsection of the file content which starts at the end element line. That makes it even faster. So if that works, we have to be super careful, to be honest, because I will be now something completely different. And if I is ever being used other than getting the line, we have to be careful. We have to be very careful about that. Yeah, but I think it's not a problem right now. I cannot think of a problem right now. That doesn't mean that there isn't one. Okay, and we got another a 10th of a second. Yeah. By the way, now I think it would be now a good time to check how it scales now with the other model, the flange fine. Flange fine. Let's just see that, because basically it's not really what I should be doing. And by the way, let's also make it comparable. Let's also run it with that one. So I said to be adding C-bar C-beam data, and now I'm doing performance optimization. Not so good from that point of view, but yeah, it was just so tempting to do that. So last we got 70 seconds, right? 76 seconds for getting the RBE file. If we are correct, we could maybe put that into half, maybe 30 seconds. Yeah. See, sometimes it's easy. Sometimes it's easy. And I mean, factor of 2, better performance. What solver do I use? In my everyday professional life, it's mostly ANSYS. So, well, depends on what problem we have. If it's a small project, it's just ANSYS Workbench. If it's larger projects, we have Hypermesh in combination with ANSYS Classic. But that's also a little bit legacy. And then we need also, or we can also use OptiStruct. But those are the solvers we pretty much using every day. We don't have Abacus. We have MSc Nastran also, but we're not using Nastran not really. We are using the Adams functionality from MSc. So multi-body dynamics and stuff like that has been done there. And to be honest, I myself, I'm not really doing too much of the pre-processing myself anymore. So that's being done by my colleagues. So I pretty much specialized also in automating stuff and doing codes. doing automated post-processing, pre-processing codes, so something like that. And then I have the whole management things on top of that too. So making offers and stuff like that. Yeah, lots to do. Yeah, so I think 25 seconds, I feel pretty good. All right. Now let's come to the part which should be implemented. So let's first hope for the best that the Talente will not punish me and just scream at my face I have too many arguments for one class. Yeah, okay. No, this is alright. So build node to property. Okay, yeah, this is now called create entities. That's perfect. Okay. The task test should work fine. I'm not even testing that. I'm just assuming that is good, and we'll just commit something. Performance boost. Yeah. Okay, and then we can work on the C-bar, C-beam stuff. Ah, by the way, I should be in bed already. It's 11 o'clock, but yeah, maybe I will just do the simple implementation of the bar beam and then be done with it. Okay, what's the problem? It's a test, right? Huh. Yeah, okay. So, yeah, because the linting excludes the tests, it's not, yeah, it's not highlighting that. But we can find that by searching for bullet. Yeah, then let's rename that as test create entities. Okay. And then there's, I mean, the test is not really that good right now. But who cares? By the way, are you a coffee or tea drinker, or are you doing the same as I do? Drink both. Meanwhile, I should say, I was not drinking coffee for all my student years. No coffee at all. But then, I think maybe 2 years back, yeah, 3 years back, I started developing a habit of, yeah, drinking coffee. But just a cappuccino. And I even can do a little bit of a barista. But not that skilled, but just a little flour or something like a heart. That's all I could do. All right, so we have that. Tea, yeah, great one. So I'm drinking. If I haven't mentioned that to you, I'm drinking jasmine tea. So, but it's not some. I mean, almost the last cup today. I have this in the intro video. You can see this little tea set. If you drink tea with milk, then it's black tea, right? Yeah. So, yeah, I have so many boxes behind me with green tea, different green teas, and jasmine tea is a pretty good one. It's pretty sweet. Cannot drink it always, but yeah, today is a good day for that. And then I have the best tea I think I have is the Enshi Yulu. And I was in China once for a conference, and I went there and bought especially that tea. Again, and I made a total fool of myself because I pronounced it all wrong. Because I said Enshi Yulu, and apparently in Chinese it's called Enshi Yulu, and the woman at the shop didn't understand the word. Uh, I just thought, I just asked, is it do you have that? And then I showed it on the phone, and Enshi Yulu, and then she went back and came out with a couple of bags, and yeah, I still have them. Still have them in the fridge. Yeah, good times. So, the commit worked. Now I can work on this MPC tools thing. So we have the data in the model readers 1D file. And the element 1D, we should see if the element 1D should have a start node or a start node and an end node, I think. Right, so we have this element 1D has a list of, no, element 1D has a node 1 and a node 2. Oh, and this is integers. No, that's not a good thing. I would like that to be a node. Node? So I think element ID is good. Property ID is good too. But this is now a node. Because that's maybe more suitable. I mean, on the other hand, I could also give it a node ID, but I don't like that, to be honest, because later I think there should be something like a direction vector which we could automatically calculate. So, yeah. Do we even need element? Why the hell? Ah, okay. It's because of the order, I think. So node is the basis for elements, so it makes sense to have that above it, because then we don't need any import statement. So that makes sense. So that's the element 1D. Okay, and now all hell will break loose if I start it, because the element, the create entities here, will just not work, because this and this, those are the start nodes. Yeah, this is the element ID. Let's tidy that up a little bit. Oh, is there a node ID to node? I think so. Yeah. Oh. How did I solve that here with the element? Oh, wait a second. This is an FEM file reader. Huh. So I think there should be a self. Yes. So that's node 1 and node 2. We can make that delete 2, comma, node 2. By the way, if you want to know why, how I'm dealing with the text editor and stuff like that jumping around, this is called Vim Motions, and this is a plugin for VS Code, which lets you do some pretty cool stuff. So for example, if I hit the letter B, that's before, that would jump to the word before. If I do that again, I can jump word-wise back. If I just press 3, number 4, and then B, it would jump 4 words backwards. And W for word would jump a word into the right direction, right, forward. And then, for example, if I'm here, I press D, W, E, I. And that's just delete word and then go into insert mode. So whenever I'm in the cursor mode like this is the navigation mode, and I insert mode, it turns then like this. Yeah. Takes a while to get used to it, but it's pretty cool. Pretty cool. For example, if I have Shift A, so for capital letter A, it will just jump to the end of the line and go into insertion mode. Stuff like that. Same thing with capital I is the beginning. And so there are a gazillion ways of navigating code or text. But I'm not a pro. Not at all. All right, so we have that. So this should now work. And now I think we can make this pretty similar to the get forces documentation. Right? How are we doing that here? So this is the forces thing, right? For MPC part ID blah blah blah, for load, forces present. Yeah, so this is all forces. Let's maybe compress that a little. This is all forces. Then let's do 1D element. And for now, let's just do master nodes. I think that's perfectly fine. Puh. No, no, no. For element, yeah. Is that? No, that's no way I have an element 1D here. Do I? Yeah, I have. But why? I think there's not much sense to that. That doesn't make any sense. Let's skip that. All right. So there should be a reader dot elements 1D. Yeah, basically that's it. Now that should be maybe self.reader. So let's see. So for element ID in self reader dot elements 1D. So those are all 1D elements. And I don't think we have too many 1D elements. So maybe it's a couple of hundred, and even that's a big model, right? So 100 or so. And then you have maybe 200 RBE elements, and then you have the looping and stuff like that. Yeah. I think that's okay. Should not be a problem performance-wise. So for every element 1D, if the MPC master node .id, why is it? Because the element ID, the element 1D, I think it still thinks that it is an ID here. But this is a node now. So, no. Oh, sorry. Ah? Hey, really? Did I just implement the same stuff twice? Wait a second. If the output shows now that I have that implemented already, I'm stupid. Yes. Oh man, I'm so stupid. Oh man, I am stupid. Yeah. So let's see if it still works. So I don't think it should be maybe above the master node ID and the master node coordinates. Should be here. Let's see if it works without the ID. And then let's just do 1D element. 1D element with the ID, element 1D ID associated with the master node. Yeah, you see, sometimes that happens. Sometimes you think of some great thing to implement, and then you realize, oh, I have implemented that already. And that's just happened to me. So I have that implemented, and the only change I now did make is something about oh sorry, I'm in the wrong model. Sorry. So, and the only change I did make now is changing from node IDs to nodes. Has no attribute. Yeah, I have been more careful with that. So this is not something which is available, but where is this then available? Wait a second. So I will search for that. Okay, it's not there. Node to property. Okay, that doesn't make any sense. How is it done here? There's nodes. Oh, and I'm giving IDs here. I don't like that. And by the way, why is this happening? That doesn't make any sense. That I'm transferring. That doesn't make any sense. So, but there should be something like a node ID to node. 100% there should be something like that. Let's see. So here there's a list of all nodes. Is that being used at all? No, not at all. So then let's make something different. That makes much more sense. Then we can do node as it is a class variable, node ID, blah blah blah, is self. Okay, so then we have that. Here it must have something like this. And now we can now do something like node as a class variable, right? So it's not the node, capital node, it's a class node. So this now refers to not an instance to it, but just a class variable. And then this is the collector where I can just go with a node ID in there and get a node as an instance back. All right, so this is what I'm doing here. Alright, did it work? So, we're working with the rigid 3D bolt. Okay, 1D element ID associated with the master node. Yeah, that's working. It's the same ID for both. That makes sense too. The only thing what does not make sense is the indent level. So we have to add 2 spaces here. And yeah, so I think that's it. So let's do the linting. Because I think then we can commit that and be done with it today. Yeah, alright, so reader defined outside init. Yeah, okay. But we need a file path for that. And block size. In the init, we don't have a block size here. We have the FEM file path. Maybe let's do the block size here too. Because then we can do the following. We can just... Because the FEM file reader, does that really do something, the init? Yeah, it does something. Then I would like to have it here, so skip that thing. Just let that be here. So let's do something like self.reader equals none. All right. Let's do some typing. So that's all strings. Yeah, so I think we are almost done with that. So that worked, and then I would say we do that again. Commit all the changes. Basic implementation with better structure. Because we have did that before, and I just did not see it. So hopefully the tests will pass too. And I think if that's the case, we can now then be done with it. And yeah, so now there is something wrong here. What is the problem? Oh, it has now an assertion error. Okay, interesting. That should not be it. Assertion error here. SVP data structure, blah blah blah. 348 charts. Let's see where this is. Node to property. Yeah. Yeah, you know what? Which one is that? Test FEM file reader. Why can I not go there? The problem here, the node to property is now a node to property. And this is not, because we're now having instances of nodes and not really IDs of nodes anymore. So how should we do that? Nah, it's not so easy. Cannot think of an easy way to fix that. We could maybe do could do something like this. Node ID to property. Something like this. Would that work? Oh, would that work? Let's see. No. Int object has no attribute ID. Wait a second. Node to property is a dictionary. And this node ID to property, I changed that in the model reader for the create entities that we just have for node in nodes. You know what? I think it's easier to just change it like this. Right? Because we don't use that thing anyway, so it's not really that bad of a problem. And here we can go back to the way it was before. Yeah, so this should then pass. Yeah, let's do it like this. Yeah, and I think then we are done with that. Then we are done with having some basic information about 1D connection to RBE2 connections and that stuff. And I think for the time being, I think this would be enough for now. Because I'm not going into the realm of dealing something which would just make a second hypermesh that doesn't make any sense, or second hyperview. I think it's better to just analyze it in the hyperview view. That makes more sense in my opinion. The only thing which I can think is maybe possible to have a simple hand calculation. So we have a force, right? And we also have the direction of the force. And so we could have something like a shear stress because we know the coordinates of the bar nodes, right? So we have node 1 and node 2. I have that in the paint here. So cannot really see my mouse here, but yeah, here we have this node 1 and we have this node 2 here. So we have this direction, then we have a perpendicular direction, and then we can map the forces from above and from below to that perpendicular direction and then see what F divided by A is. And we could do something like this. Besides that, we could also improve the output a little bit more, having something like a structured data and something like a hyperview visualization mode, something like this. But that's all for another day. For now, I would say the things we did here is enough for having that being merged. And let's do that right now. So pull request, we have to do another pull request. So review, I cannot do that. I assign myself as an assignee. Label should be an improvement. Enhancement, create pull requests. We have 2 commits. Is that correct? Performance boost and basic implementation. Yeah, that makes sense. Okay. Did it do that? Okay, we have the pull request. We check the files changed real quick. So that's some typing. We have put the class node above. Then we change that to being node. That's maybe a little bit inconsistent because We have it here as a node, but in the other one we have an element. Yeah, not sure. That should be consistent, but that's for another day. So MPC tools now has self.reader, right? So this is new. Yeah. The create entities method. Yeah, I think that makes sense now. All right, then let's merge that into the development. Merge pull requests and delete the branch. And then I say again, thank you for being here, for contributing, for commenting, for just talking. And yeah, I see you guys maybe tomorrow. Just as a notice, I will maybe not be able to do every day streaming like this. So I'm still working on maybe a schedule, maybe something like doing streams on Tuesdays and Thursdays or something like that. Yeah, I just wanted to get a quick jump start into the tool right now because I wanted to have that finished more or less. And we made some progress here. So I would say it's pretty cool already. There's still a lot to do, like always, but I think this far it can be used now as a prototype in production, I think. Yeah. So that's the state of the tool for right now. Let's just check out the Git graph because that's always satisfying to see what has been done. So we had made some progress here from the initial commit. And this is now 10 days, more or less, 11 days. Yeah. And basically, yeah, the only thing which I think should be definitely happening is a renaming from SPC tools to MPC tools because we don't really do something with the SPC tools. Maybe that's also something which I can do in the future, but I'm not really sure what this should be about. Maybe to check for connected parts. So SPCs connected to this part has a summation of this force, something like this. This could be it. But to be honest, not really sure if that makes sense. That seems to me like edge cases, which make sense in a certain way, but don't make sense in another way. So it depends on the model very much. And so I don't think it's too big of a deal. But we could do definitely something with multi-load steps. What is it if we have multiple load steps? That may change everything. And MPC tools renaming is not an easy task, I think, because if I do this, then I have a show preview and there's a lot of renaming happening. And if that runs now, I would be surprised. Yeah, okay, so this does not work because SPC forces has to be replaced by MPC forces. MPCForces, yeah. Let's just do all that. Task run. No module named. Hey, I saved it, right? No? Yeah. Do you want to save the changes made to MPCForces reader? Huh? What is this? Test MPCForces reader. I don't know. Save. Man, close all and save all. Save, save. Okay. Because maybe that was it. Yeah. Well. Okay. Then it's not that much of a deal, but yeah. It's just ugly to commit that. I don't really want that, but yeah. Renaming of the main module name. So this is just, it's a minor commit, but if that runs now with all the tests and the linting and stuff like that, I'm pretty surprised. Because normally I know that it is a heckle to get this working. Right, so it's not done with one commit solution. Yeah, you see, and I think I will not do that today. What is it? Task lint. 0 from 10. No way. Task lint, let's just check it. Yeah, it's always the same. I cannot stop. Cannot stop. Hey, this worked. Task test. Is it a PyRC config? Ah, okay, this does not work. Module not found. MPCForces tool. Why the hell does the tests? Why is the test not? Ah, the patch. Yeah. You see, so we have to change every. Well, basically, we can just do a something like that, right? Not doing for everything here. So those two, and then this here maybe also. No. Test. Was it 3 tests? 5 failed. It's more than those. I cannot see them. Maybe it's not test files, but the tests inside a file are counting it. Okay, still a thing. Test model reader. Huh? That cannot be. It was not saved. And then the test maybe also not saved. Alright, so this worked. Now let's also check the pre-commit. Is there something here? Yeah, for sure. So changing the module name is not an easy one. So let's commit those as well. See if that worked now. And then it's time to sleep. Yeah. It's time to sleep. But I still having issues. What is that? Git C user config whatever. Python formatting failed. Python formatting to black whatever. Huh? The PyRC was changed, right? Ah. Still one missing. Bam, bam. Okay. I'm getting stupid. To be honest, it's more than time to sleep. But I enjoyed this session, to be honest. So it's always a pleasure to do something on here. Oh god. I'm having 6 messages from the coach. So I guess I will be checking that out too. Alright, guys, it's been an honor. Yeah, I wish you have a wonderful day, night, whatever it is for you. Thank you for being here and staying with me the time. And yeah, so I'll see you tomorrow, maybe not. Let's see. But I think the tool is now very able to be used into production, and yeah, see, as a prototype for sure, but yeah, to just get some field data and to improve it further. All right, guys, take care. Bye bye.